In this video, I'm going to go over more properties of log functions. You'll see here in part 1 of the notes, we did these in a previous video. These are kind of the basic properties, like you'll notice when the bases are the same, log of 1, or when you have a base raised to an exponent that has a logarithm with that same base. So we're going to focus on part 2 in this video, which has a lot of properties. You're going to get pretty good at this, using these properties to expand a single logarithm into many, or take many logarithms and condense them into as few as possible. So I'll start kind of just a brief overview here. You can see the first one says the log of a product. So if you have two numbers being multiplied or to anything being multiplied in the argument, you can break them apart into two logarithms with the same base connected by addition. And you can go vice versa here, right? So if they are already apart, you can put them together. With the log of a quotient, it's very similar, but with division, you're going to think subtraction, right? And then when you have a power on your argument, you can move that power to the front and it multiplies by the logarithm, or you can move it to the back, right? You'll see in the other one, you can take the power, the number in front and make it a power. And then finally, we've kind of already talked about this in some of our solving, but if you have one log on each side with the same base, you can drop the logs and set the arguments equal to each other. All right, so I'm going to do a ton of problems in this video. It's going to be a fairly, beefy video and very meaty video, lots of problems. So skip around, try some on your own, pause, do a couple before I practice them to see if you get them right. Okay? All right, here we go. So the first section is going to be about expanding. So what I first notice here is we have a power that this argument is being raised to. So I'm going to go ahead and put that in front, and it's going to multiply by the log base 4 of u times v. Now, because we have u times v, I can expand that. So I'm going to have 3 times log base 4 of u plus log base 4 of v. All right, and to finish this problem, I'm going to take that 3 and distribute it onto both of these logs. So 3 times log base 4 of u plus 3 times log base 4 of v. And that's it. That's kind of what we're doing. Everything is just, a variation on that part A. Let's do part B. Again, I see multiply. All right, so I'm going to write log base 4 of u plus log base 4. And this has a lot going on here. Watch how I rewrite it. I'm going to write it as v to the 2/3 power. Right? Remember, with the radical, whatever the index is, that's your denominator, and this power inside is the numerator. So now I'm going to take that 2/3 and move it to the front of that logarithm. Be careful here. This should go in front of its own logarithm, so it should go here. So plus 2/3 times log base 4 of v. All right, and that is it. That's as expanded as we can. Okay, the next one. This time we have division. So I'm going to break this up into two logs with subtraction. So u squared minus log base 4 of v cubed. And hopefully by now you recognize what's going to happen with those powers. They're going to go to the front of their respective logs. So 2 times log base 4 of u minus 3 times log base 4 of v. And that's it. Okay, last one here in this section. I'm going to take this 5 and move it in front like we did in A. So it's going to multiply. And I'm going to write 1 over. And I'm going to go ahead and rewrite it right now as v to the 1/2 power, right? Anything when you take the square root of something, you can rewrite it as a power of 1/2. All right, now I'm going to break that down into two logs, log base 4 of 1 minus log base 4 of v to the 1/2 power. Now I'm hoping that you see that we do have a log base 4 of 1, right? And log of 1, no matter what the base is 0. So I'm going to go ahead and write this as 5 times negative log base 4 of v to the 1/2 power. And I'm going to move that 1/2, which is a power, to the front to multiply by this 5. So that's going to become 5/2, and it should put that negative up front with it. Negative 5/2 log base 4 of v. Okay, so I think the hardest part here was recognizing that log of 1. Okay, now we're going to go the other direction. We're going to write them as one logarithm, or as few things as we can. So this is two natural logs. Remember, the bases are e, and we're going to combine them. I see subtraction, so I'm going to use division for my two arguments. So 8 divided by 2 is going to give me the natural log of 4. All right, I don't need you to find out what that is. Go ahead and just leave it as the natural log of 4. Okay, the next one. I'm going to move that 2 to become a power. So the natural log of 5 squared plus the natural log of 4 minus 3. That's the natural log of 25 plus the natural log of 4 minus 3. I notice that these two logarithms have the same base and they're connected by addition. So I can put them together and I'm going to multiply those arguments. So 25 times 4 would be 100. So the natural log of 100 minus 3. And that is as simplified as I can get because I don't have a calculator, so I'm going to leave it like that. Okay, same idea. All right, this time we have a log base 7. I'm going to move this 4 to become a power. So log base 7 of x minus log base 7 of y to the 4th power. And then I do see subtraction here. So I'm going to write them as 1 log with base 7, where my argument is x over y to the 4th power. Okay? That's as simplified as I can get. Let's try b. Very, very similar. Take this number in front and make it a power. Log base 5 of x plus log base 5 of y to the 1/4 power. I'm going to take a moment and rewrite that power to be a radical, right? So raising something to the 1/4 power is the same as the 4th root of y. Now I'm going to put them together with multiplication because I do see addition. So log base 5, and my argument is going to be x times the 4th root of y. All right, so that is 1 logarithm there. Okay, let's do the next one, part C. Notice this one doesn't have a log with that 2, so be careful with that. I do have 2 logs, though, with the same base, connected by subtraction. So I'm going to write log base 5 of x over y, and then plus 2. So now when I look at this, I can't do anything else because I don't have a log with that 2. So that's actually finished. Let's do D. Now this 1/2 I'm going to distribute to be in front of both of these natural logs. So I'm going to write 1/2 natural log of x minus 1/2 the natural log of y. Then I'm going to take those 1/2s and move them to become powers. So the natural log of x to the 1/2 power minus the natural log of y to the 1/2 power. I've already mentioned this at least once, a second time when it was to the 1/4 power. But when you raise something to the 1/2 power, that's the same as the square root. So I have the natural log of the square root of x minus the natural log, excuse me, of the square root of y. Now I can write them as 1 log, where my fraction is the square root of x over the square root of y. And if you wanted to, go even farther, you could actually write them as 1 radical of x over y. All right, so that's it for part D. Okay, a few more, and then we'll be in our last section. So this one has a lot, right? It's got 3 logs that we're trying to put together. So I do see a couple of numbers in front that I will make powers. So I'm going to write log base b of x cubed plus log base b of 5x plus 2 minus log base b of 7 squared. All right, I am going to take this x cubed, right, because these 2 logs are connected by addition. I'm going to distribute this x cubed times each of those. So it's log base b. All right, now watch what I put here. 5x times x cubed is 5x to the 4th power, plus x cubed times 2 is 2x cubed. So that takes care of those 2 logs. And then minus the log base b of 49. All right. Now to finish this to be 1 log, I do see subtraction. So I'm going to write for my argument here, 5x to the 4th power plus 2x cubed, and then over 49. Because of that subtraction, I do need to do division. So that is it for letter E. Let's do letter F. Now letter F, I do see a number in front, so I'm going to make that a power. Log base 3 of 6 squared minus log base 3 of 4. That 6 squared is going to become 36 minus log base 3, of 4. When I have subtraction, I can rewrite this as 1 log, where I'm going to divide these numbers. And we can actually do that division. 36 over 4 is going to be 9. And then you might notice here that actually this you hopefully should know, right? If you forgot how to do this from a couple videos ago, right? You should be thinking, oops, try again. Supposed to be a question mark, sorry about that. 3 to what power makes 9, right? In my head, I'm thinking 3 to what power makes 9? And that answer is just 2. All right, so just be aware, always on the lookout of can we simplify at the end. Okay, last two. All right, so this says to essentially use your properties to expand them as much as you can, and then we'll use this understanding that log base a of x is the same as 3, and log base a of y is the same as 4 to get an actual value here. So log base a, I'm going to split these up, right? That is multiplication. So I'm going to write base a, that looks like a 9, let me try again. Base a, there we go, of x squared plus log base a of y. Move the 2 in front, so 2 times the log base a of x plus log base a of y. And now I'm going to replace, like I just highlighted earlier, the log base a of x, they said, is equal to 3, and the log base a of y is equal to 4. So that's 6 plus 4, which is 10. All right, last one here, I see division. So write log base a of x minus log base a of y squared. Move that power to the front, and it's going to multiply by that log. And plugging in, I have log base a of x is 3 minus 2 times log base a of y, which is 4. So that's 3 minus 8, which is negative 5. All right, guys, that's it for this video. Check out the homework. Check out, if you have any questions while you're doing them, come see me. Again, this can take some time to get used to, but start to feel comfortable going from one log to many and many logs to one. All right, good luck.